Here we have a final projectile example where a projectile is given an initial velocity of 25 meters per second at an angle of 30 degrees with respect to horizontal at a point 18 meters above a horizontal plane. So the object is going to follow a parabolic path and end up displacing vertically 18 meters in the downward direction. Now the initial velocity at 25 meters per second at 30 degrees can resolve into an initial x velocity and an initial y velocity. We find the initial x and y velocities just using the vector properties of velocity. 25 meters per second times the cosine of 30 degrees gives us our 22 meter per second x velocity, which will be constant. 25 meters per second times the sine of 30 degrees gives us 12.5 meter per second initial y velocity, and that 12.5 meters per second is in the upward direction. Now, since we're using a standard coordinate system, the positive y direction will be upward and will be in just about any situation of this nature now. Our y displacement is therefore negative 18 meters, and our y acceleration negative 9.8 meters per second squared. The rest of the analysis is almost identical to the analysis that we've already done. We find the final y velocity, which will be negative, and we'll take the square root. Remember, when we take the square root of both sides to solve an equation, as we would with vfy squared equals v naught y squared plus 2ay delta sy, we can take either the plus or the minus, whichever one fits the situation. In this case, since final y velocity is negative, we use the negative here. And we get about negative 22.6 meters per second for the final y velocity. The average y velocity we obtain by averaging the initial y velocity, the 12.5 meters per second, and the negative 22.6 meters per second. And we get negative 5.1 meters per second. Dividing the average y velocity into the y displacement gives us the 3.5 seconds required for the object to reach the final position. And then our delta Sx is easily obtained by multiplying the 22 meter per second constant x velocity by the 3.5 second time interval to obtain the 77 meter x displacement.